Hello doctor, my name is Zoe Hana Anak Mapri and my matric number is 2400-5964/1. And in today's video, I am going to talk about defibrillators and the second order circuit. Now, what is discharging of a defibrillator? Discharging of a defibrillator is a step in delivering a controlled electric shock to the patient's heart to restore its normal rhythm. The stored energy in the defibrillator's capacitor will be released through electrodes attached to the patient's chest. This causes depolarization to a large portion of the heart muscles simultaneously, which gives an opportunity for the heart's natural pacemaker cells to re-establish a normal sinus rhythm. Is there a difference between charging and discharging of a defibrillator? After doing some research, yes. Charging only involves the interaction between the resistor and the capacitor. This shows the charging of a defibrillator is a first-order process. Discharging of a defibrillator, however, is more complex and includes the interaction of both the inductor and the capacitor as energy storage elements. This shows that the discharging process uses the second-order circuit. As you can see from this slide here, the discharging circuit of a defibrillator is modeled as an RLC circuit consisting of a capacitor, an inductor, and a resistor. The capacitors of the discharging circuit stores the high energy electrical charge to deliver a high energy pulse to the patient's heart. Inductors in the circuit helps in shaping the discharge wavefront to control the rate of energy delivered while helping to reduce harmful voltage spikes. The resistor cannot be seen in the discharging circuit. That is represented by the combined resistance of the circuit components, including the patient's body. Now, how is the flow of the discharging circuit? The current flows from the positive terminal of the capacitor through the switching and the waveform shaping components, which is the inductor, and into one electrode, exits through the other electrode and returns to the negative terminal of the capacitor. Now, why is the second order circuit commonly used in defibrillators? The second order circuit provides more control over the energy delivered and the shape of the waveform. The key reasons for using a second order circuit is its ability to optimize the shock efficiency and effectiveness while minimizing damage to the patients. Now, there are two types of waveforms formed by the defibrillator. One of it is monophasic waveforms and the other is biphasic. Monophasic waveforms are produced by older defibrillators and only delivers a single pulse of a current in one direction only. Monophasic waveforms also requires high energy, which is around 360 joules. For biphasic waveforms, however, the current flows in one direction then reverses. This requires less energy, which is around 150 to 200 joules for the same therapeutic effect. It helps to reduce damage to the heart tissues. During phase 1 of the biphasic waveform, the capacitor discharges through the circuit, sending a current pulse in one direction. Phase 2 of the biphasic waveforms, the circuit reverses the polarity, sending a smaller pulse in the opposite direction. This two-phase approach ensures effective defibrillation with less energy and reduced risk to the patients. Now, what is the relation of second-order circuit with the defibrillator? First of all, in the aspect of waveform shaping, the second-order circuits can produce damped sinusoidal waveforms or customized waveforms. The inductor modifies the discharge dynamics, controlling the rate of current charge and shaping the waveform. Next, through energy efficiency, by shaping the waveform, second-order circuits ensure that energy is delivered more efficiently to the heart. They minimize excessive energy loss, reducing the risk of burns or myocardial damage. And lastly, in the form of biphasic waveform implementation. Biphasic waveforms require precise control over the current flow and polarity reversal, which second-order circuits facilitate. The inductor helps smooth transitions between phases, improving defibrillation success rate. In conclusion, the discharging process of a defibrillator releases energy from a capacitor through an RLC circuit, sends a controlled electric shock through the patient's chest, and uses carefully shaped waveforms to depolarize the heart and resets its rhythm effectively. That is all from me. Thank you very much.